So now we're going to jump a few more sections further. We went from 5.1, now we're going to go to 5.7, because I feel like these sections all kind of go together. They all deal with inequalities. So now we're going to go and graph inequalities, but now it's going to be on a coordinate plane. So how do you graph inequalities on a coordinate plane? Before we just did a number line, now it's going to be on a coordinate plane or a graph. So instead of having one variable, we're going to have two, and we'll graph it in 2 dimensions. So just remember, just like when we had number lines, if you see the less than sign or the greater than sign, that means on a number line that it's an open circle. It's not included. To show that when you're drawing a line, you want to make it dashed. That means it's not included. On the other hand, if you see a less than or equal to sign or a greater than or equal to sign, that means you would actually draw a line as a solid line. For the most part, when we're going to graph one of these, you just treat it as if there was an equal sign here. If you look at example 1, it says graph y is less than 3 over 2x minus 4. It's the same thing as if it were equals. The only difference is on how you draw it, dash or solid, and then we also have the shade. So there's really no difference. How do we graph this as if it were y equals? We just take our y-intercept, because it's in slope-intercept form essentially. That would be at -4, so you put a dot at -4. And then we're going to go up 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Oh, man. One, two, 3 over 2. You just keep doing that. And you're going to draw a line. 1, 2, 3 over 2. You have to decide whether it's dashed or solid. So before you actually draw it, you're going to look and see if it's dashed or solid by looking at the symbol. And since you have just less than, it's going to be a dash line. So we're going to have the dots, but it's a dash line through everything. Like so. That means it's not included. The last part is to figure out where do you shade. You're either going to shade above the line somewhere or below the line. So here's the easiest way, I guess a surefire way of figuring out where to shade. What you do first is you pick a test point. So you can pick any point you want as long as it's not on your line. So you pick any point you want. The easiest point that I usually do is pick 0, 0, as long as my line doesn't go through there. We're going to pick this test point as 0, 0. That's your x, y. And we're going to plug it into this inequality. So we'll plug it in. 0 is less than 3 over 2x minus, oh, not x, we're plugging in 0 as well, times 0 minus 4. So that makes it really easy, because if you do 3 over 2 times 0, that makes it 0. So you have 0 is less than 0 minus 4, or 0 is less than -4. And then you ask, is that a true statement or a false statement? Is 0 less than -4? No, -4 is a smaller number. So this is false. So what you do in this situation is we look over and see, oh, 0, 0 is not part of the solution, so it's not where you shade it. It has to be shaded on the other side. So then we'll shade down here. And fill it all in. Something like that. There. So you just lightly shade it. You can do it with a pencil. Shade the bottom part. So I'm going to skip ahead a little bit, and we're going to, before we do example 2, we're going to go ahead and go through the steps of how do you know where to shade, so in case you ever forget. So what I do, you pick a test point, any test point you want, as long as your point is not on the line. It wouldn't make sense to put choose a point that's on the line, right? If you choose a point that's on the line here, we already know that it's not included, so it would turn out to probably be a false statement. So you wouldn't pick anything else. You can pick either side, but it doesn't matter. Then you're going to substitute that point xy into the inequality. That's what we did here. We substituted 0, 0 into the inequality, original inequality. Step 3, simplify each side. So when we simplified this, we got 0 is less than -4. See if that's true or false. So if the statement is true, you shade the side where the point is. In our case, it was false, so we shade the opposite side. Okay, now let's do another one. So you can graph this one with the shortcuts if you want, or you could solve for y. It doesn't really matter. I think in this particular case, I will solve for y, and then we can just do what we've been doing. It takes about maybe a little bit longer to solve for y. So if we get y by itself, we're going to first move the 3x over by subtracting it. This one goes away. Bring down the negative y is greater than or equal to -3x minus 1. And then what you have in front here is a negative y. On this negative y is you have a -1 technically. So we can divide both sides by a -1. And don't forget, it goes into both of these things. And when you do that, don't you remember what happens to this greater than sign? It changes to a less than or equal to sign as soon as you divide by a negative number. So now this on this side, we divide each one by -1, so this becomes a positive 3x and a positive plus 1. So we can graph that pretty easily. The only reason I didn't really do the shortcut on this one is because I don't have a ruler to draw the lines. So we start at 1, and we're going to go up 3 over 1. Remember, your slope is 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Let's keep doing that. Okay, and then we're going to see whether or not we draw a solid line or a dashed line. It all comes back to this symbol here, which means it is a solid line. So you connect the dots as best you can. There we go. And the only other new part is a shading. Again, you can pick a test point. You can pick whatever point you want. I tend to choose 0, 0 as long as I can. So if you look here, 0, 0 is not on the line. That's good. That means we can choose it. So if we plug in 0, 0 into this inequality and we get a true statement, that means we would shade on this side. If it's false, we shade the other side. 0 is less than or equal to 3 times 0 plus 1. Plugging in 0 for both x and y. 0 is less than or equal to, that would be 0 plus 1, which is just 1. So is that true? Is 0 less than or equal to 1? That is true. So we shade the side of the point. So that means 0, 0 is included, so this whole thing is shaded. All below it. I should probably make this bigger. This whole thing gets shaded. Okay, it doesn't look that great, but it's all right. It's the best I got. So you might be thinking, well, can't you figure this how to shade it without having to do a test point? And yeah, you usually can. If you go back to the first one, if it's written out like this, where y is already by itself, and you see the symbol less than, that means you shade below the line. So if your line is diagonal like this, that means you shade below it, down there. That's only if y is by itself. Because if you go to the example we just did, and you look at the original problem, right? This has a greater than sign, which you would think it would be above the line, but after we solved for y, it changed to a less than sign because there was a negative number in front of y. So if that happens, then you have to remember, well, the sign changes. So if that happens, then you have to shade below the line, in which we did in this case as well. So it really just depends. If you can figure out which direction the sign is going to be, if you have a less than sign, it goes below the line. If it ends up being greater than when y is by itself, you can shade above. So you don't have to do the test point every time if you understand the shortcut. If you don't, just do the test point. Now we're going to do two more. Two more examples. We have an A and B on this one. Graph the following inequalities or describe the equation of the given graph. So we're going to finish this one here because there's a negative in front of the y. There really is no other x value, right? There's just a y here. So you should remember, whenever you just see one variable, we're going to have either a horizontal or vertical line. I'm going to finish this by dividing by a -1 on both sides. And that magically flips this sign. Y is now greater than or equal to a -2. So what does that mean? How do we graph this? This means you go on the y-axis and you put a dot at -2 down here. And then that also means that you draw a line going horizontal. It is not a vertical line. It goes horizontal. It does not actually cross the x-axis. It stays at -2 the entire time. Now this has a line underneath it, so it's going to be solid. So you can draw a line going all the way across. Both ways. And then you can choose a test point, or just notice, hey, y is by itself. It says greater than. It should be above the line. If I choose a point like 0, 0, that means this should be a true statement. So if you plug in 0, well, we only have one variable. We're going to plug in 0 here. 0 is greater than -2. That is absolutely true. So you would shade above. So we can do that here. So if this one ends up being a horizontal line, you can imagine what this is going to be on the other side once we get to just an x value. This one you don't have to solve at all. It just says x is greater than -1. So we go to -1 on the x-axis. That's right here. Put a dot. Now, this means that it does not change from -1. It stays there. It's going to be a vertical line. However, there is no line underneath it, so it's dashed. This kind of goes back to vertical lines means you have an undefined slope. So, undefined slope. Horizontals are 0 slope. And since it says greater than, well, which side is greater than? You have to think about that. What values would be greater than -1? That would be like 0, 1, 2, 3, 4. So it should be over here. I'll do a test point. Again, 0, 0, which means you have 0 is greater than -1. Is that true? Yes, 0 is bigger than -1. So you would shade the right side. So maybe that'd be harder to think about the shortcut if you didn't know what was the top of the line, above the line or below the line. You just give a good old shade. All right, the last one we're going to do is actually creating the equations ourselves. So we already did one just like this where we shaded it and it was a dashed line. So a dash means we're going to use a less than or a greater than sign. And we already know that vertical lines look like this with just x's in them. So we're going to start with just x. I'll keep the sign out of it for now. Where is it going through on the x-axis? Looks like it's going through the number 3. So we have x and 3. Now we have to figure out where it's shading. If it's shading to the left, that should be less than. It's not equal to because we have a dashed line. You can check your answer. Again, you can use 0, 0, or plug in 0 here. Is 0 less than 3? That is true. So if it's true, that means we shaded the right side, and that's your answer. For part D, we actually have a diagonal line, so we have to figure out our slope. We're going to kind of create it like the very first one we did, where it looks like this. We want to make the same thing. We can find the slope, we can find where it crosses the y-axis, and then we just have to figure out the symbol that goes in between. So let's see. We're going to have y, then we're going to have a symbol in here. I don't know what that is yet. We need our slope with x, and then we need the y-intercept. So the y-intercept is right here. That would be at 2. So I'm going to have a plus 2. Now we got to find the slope. Try to find a place where it goes between two blocks perfectly. I feel like right here works. Right here and also right here. So let's count blocks. You're going to go down 1 over 2, down 1 over 2. So down 1 would mean -1 divided by 2. That's our slope. And where are we shading this? This would be, I guess you would say, above the line. So it should be a greater than symbol. It's dashed, so no line underneath. I would test 0, 0 just to make sure it comes out to be a false statement. 0 is greater than -1/2 times 0 plus 2. So that'd be 0 is greater than, this gets wiped out, 2. Is 0 bigger than 2? No, that's false. So we have the right symbol. So I'll just rewrite it. It's going to be y is greater than -1/2 x plus 2. So there's an example of going from the graph to the equation. And that is the end of this section. The rest of it you should do. And again, send me the answers on Teams. So you're going to do Team Huddle, which is EF. There's 2 more parts to this, E and F. And then 1, AB, CD, and then the master, there's 6 of those. So there's quite a few you have to graph. I think I need to help you on number 4 a little bit. If you're trying to solve this one for y, what you would want to first do is multiply both sides by 5. I want to add this in here real quick. So that way the 5's cancel. So you get 2y plus 3x less than or equal to 20. Then you can do it from there. Subtract your 3x. And after you do that, you can divide by 2. So you can go ahead and finish that one off. I kind of want to start that one because it looks kind of daunting at first. Everything else you should be good with. Finish it off and then send it to me. And that's all you have to do for this work. No extra homework on top of that.